Alright, welcome to this video. So we're going to be talking about properties of quadratic equations. Some of this will be review. Some of this will lead us into what we will be discussing here in pre-calculus. Our learning target is I can define a quadratic function and use the zero product property. So first, before we do that, I'm just going to review some basic things of quadratic functions that you have learned last year, but you will also need to review for this year. So just as a background knowledge, in the real world, where parabolas came about, or also quadratic functions have the shape of parabola, Galileo in the past found that all objects thrown will follow a path in the shape of a parabola. Parabolas are also in architecture, such as this bridge. So just some background. Of course, parabolas and quadratic functions are useful in the real world, especially if we want to be a builder, or if you want to study any of that. That's the usefulness of it. So here's some basic definitions. The graph of a quadratic function is called a parabola. So that's why I've been using it interchangeably. I say quadratic function or I say parabola. The standard form for a quadratic function is y equals ax squared plus bx plus c, where a, b, and c are constants and a cannot be equal to 0. If a was 0, then this whole x squared term goes away, and what you would actually have is a linear function. So that's why a cannot be 0. This is your standard form. The parabola opens upward if the a term is positive, or downward if the a term is negative, and it intersects the x-axis at c. At the c value, it intersects the y-axis at c. And so this parabola intersects the y-axis at the c value, y equals c. So there's some basic properties you should know of quadratic functions. Let's talk about the factored form. So the factor form, this is where you use the box method to factor out. Exist, where exist looks like this. So y equals a parentheses x minus r times x minus s, where basically a, r, and s are the constants, and again, a can't equal 0 for the same reason above, because if a were to equal 0, our x squared term will disappear. So in this factored form, you learn that at r and s, the parabola intersects the x-axis. So those are your x-intercepts, r and s. So at x equals r and at x equals s is where the parabola intersects the x-axis. Then there's also another form called the vertex form, where you have f of x equals a parentheses x minus h all squared plus k, where a, h, and k are constants, and again, a cannot equal 0. Again, if a were to be equal to 0, you'd have a line. And the vertex in this format is found at h comma k. So either the highest or the lowest point, depending if the parabola is opening up or down. All right, let's go on to some more properties of quadratic functions. So the highest point, a maximum of a parabola, is one that opens downward. And the lowest point, a minimum on a parabola that opens upward, is called the vertex. The imaginary vertical line passing through the vertex is called the axis of symmetry, because quadratic functions are perfectly symmetrical if you draw a line vertically up and down. So here we go. So this is what I was talking about. The axis of symmetry cuts vertically up and down through the vertex of your parabola, and basically you have a mirror image because it's perfectly symmetrical. And this right here is your vertex. This one is a parabola that's facing downward. You notice that the vertex is up here, so this one would be a maximum, and for this one the vertex would be a minimum. So these are just some properties. The y-intercept in this graph right here occurs when all the x values are 0. So basically this y-intercept right here, when the x value is 0, you get your y-intercept. And for this parabola, it's going to be at y equals -1. And the y-intercept for this function occurs when all the x values are 0. Again, when there's no x movement, you're only up here. And your y-intercept is actually at the vertex of this parabola, which is going to be at y equals 4. So this one's a coincidence that is at the vertex is the y-intercept. For this one, it was over here, which was not the vertex. So just some things to pay attention to. So, finding the zeros of a quadratic function. So let's say that we were asked to find the zeros of x squared minus x minus 6. Finding the zeros means to find where the parabola intersects the x-axis. At what x values does your parabola intersect the x-axis? Similar to here, it's like asking what are these x values or what are these x values where my parabola is intersecting the x-axis. So the zeros of a function occur when the function intersects the x-axis, or again, that's when y is 0. So you can find the solution by factoring. So this factors into, first you must set your equation equal to 0 because that's how you find when your when the parabola crosses the x-axis, when the y is 0. And as we know, my y is also f of x. So y and f of x are the same thing. So that's why I set it first equal to 0. So it's actually very important. First set it equals 0, then you factor it. We're going to talk a bit about how to factor later on, but I just want all of us to understand right now that this is the process. So in this scenario, right, we factored it, and it has the solutions at x equals positive 3 and at x equals negative 2. If you remember, it's always kind of the opposite of what the factored form is. So again, what does it mean to find the zeros of a function? This means that this function intersects the x-axis at the x values x equals 3 and at x equals negative 2. Alright, so that's how to find the zeros of a quadratic function. Again, we're going to get into detail about this later on. Another thing that you should know, and that's going to come up later again, is the quadratic formula. The quadratic formula, we use it to help us find zeros when we can't factor a quadratic function easily. But we can use the quadratic formula actually any time to obtain the zeros of a function. Here is the quadratic formula. Basically, I'm returning to that problem that we just did, and I'm going to be using the quadratic formula to show you that we're going to get the same zeros as when we factored. Again, my first step, I usually like to set my equation equal to 0 because when y is 0, that is when you get your x-intercepts. So that is where that's coming from. So I know my a value is 1, my b value here is negative 1, my c value is negative 6, a, b, and c. So basically I plug into my formula, do the math here, and you get 1 plus or minus the square root of 25 all over 2. So 1 plus the square root of 25 is 5. So 1 plus 5 is 6 divided by 2 gives you 3. Now let's do the minus 1. 1 minus 5 is going to be negative 4 divided by 2 gives you negative 2. So as you can see, we got the same solutions by using the quadratic formula. So you could factor, or you could use the quadratic formula to find your zeros of the quadratic function. So I'm just showing how these things are related to each other. You could also find the solution of the zeros by graphing. So if you use a graphing calculator or Desmos, you can visually see where the parabola intersects the x-axis. So as you can see, it's at 3, and at x equals negative 2. So that should be a negative, but yeah, because that's a negative side, and at x equals negative 2. You could graph using a graphing calculator, or you could create an input-output table, plot the points, and then you'll notice that the parabola crosses the x-axis at x equals 3 and at x equals negative 2. Again, when the y value is 0, because there's no movement on the y-axis. It's where the x values, the x-intercepts are at. And just so you can see, this right here is a parabola such that no zeros exist because it does not cross the x-axis. This parabola is going to open forever downward. It's never going to come back up, so it's never going to have any zeros. So this is an example where no zeros exist. In this example, if you were to use the quadratic formula, if you knew the function and you knew the a, b, and c, you would see that you get a square root of a negative number. Because the square root of a negative number is not possible, that's how you know that, oh, this has no zeros. So that's just something to keep in mind. Okay, so let's move on to the zero product property. So we just went over a bunch of quadratic function things that are a bit review, maybe a bit new, right? We're going to delve into those details later on, But actually today's focus is on the zero product property. So let's talk about what is the zero product property. So we first need to understand the zero product property and how this property will help us find the zeros of a quadratic function before we actually start factoring, before we actually start using the quadratic formula. We first need to know this property. So here's the zero product property. If A times B is equal to 0, then either A is equal to 0 or B is equal to 0. So what does that mean? So that's like saying, like 3 times 0 is equal to 0. I know that 3 is not 0, but 0 is 0. So one of the values must be 0. So if A times B is equal to 0, then I know that either my A is 0 or my B must be 0. That is the zero product property. All right, let's see how to use this. So the zero product property works whenever you have something equal to 0. You need to have the equal to 0 to work, for this to work. So you see A is x plus 5. My B is 2x minus 1. See how it's A times B? It's x plus 5 times 2x minus 1. So right here, we're going to be using the zero product property. So the property says if I have A times B is equal to 0, then I know that either my first term is 0 or my second product is 0. So let's go ahead and set each of those equal to 0. That is me applying the zero product property. All right, so it says find all x solutions to this equation. So what x values makes this property true? Basically, at what x values gives me my zeros here. So let's solve for x for this one. So for this one, I'm going to subtract 5 both sides. For this one, I'm going to add 1 and then divide it by 2 to find my x. So here, I already subtracted 5. I got x equals negative 5. That's one solution. Over here, I'm still going. I'm going to add 1 to both sides. That cancels. You get 2x equals positive 1. To solve for x here, you got to divide both sides by 2. You get x equals 1/2. Here, at x equals negative 5 and at x equals 1/2, those are my two solutions. And I'm done. That's me using the zero product property. Again, you can only use this property if you have a product, which means a multiplication happening, and it's equal to 0. So just be mindful of that. Let's go over to example 2. All right, let's take a look at one that has a product of 3. Even though you have a product of three things happening, see we have 2x times 3x plus 5 times 2x plus 1 equals 0. It's a product of 3 different expressions. You can still use the zero product property. Step 1, set all products equal to 0. All of them are equal to 0. Step 2, you must solve each of the products for x. That's how you're going to find all the x values that make this equation true, that make this equal to 0. So here, 2x equals 0. I'm going to divide both sides by 2. 0 divided by 2 is equal to 0. Remember, when 0 is on top, it's 0. Right here, we're going to get x equals 0. Here, I'm going to subtract 5, then divide it by 3. Over here, I'm going to subtract 1, then divide it by 2 to get my solution. I'm going to show you all of this all at once. So here, I already told you all, I divided both sides by 2, and I got x equals 0. Right here, I subtracted 5 both sides to get 3x equals negative 5. Right here, I'm just subtracting 1. This one's already done. I already got x equals 0, so let's move on to these two. So this one, I just got to divide by 3 to solve for x, and I get x equals negative 5 over 3. Over here, I get 2x equals negative 1. To solve for x, I'm going to divide by 2 to get x equals negative 1/2. So I have 1, 2, 3 solutions. You don't have to show it just how I'm doing it like that, all at the same time. You can just do them separately if it helps you focus on what you're solving for. Let me just make sure that it's clear that it's kind of like this. So this is over here. The line should look like. But yes, so basically you should set each product equal to 0. And from that, you're going to be getting your 3 solutions. In this case, there's 3 solutions because I have a product of 3. Right? It's not always going to be that way. So that is example 2. Your task is going to be all about the zero product property. Later on, we're going to be also exploring with other properties of quadratic functions, such as factoring, such as finding the y-intercepts and other properties of the quadratic function. But for right now, we're going to be focusing on the zero product property, which we just went over. So please make sure you use your notes. All right, good luck. Let's shut off this video.